So 10.5 is all about angles in the circle. The ones that we've talked about so far, so we've talked about central angles. Angle ACB is referred to as a central angle, and that is equal to the intercepted arc. So again, let's say this arc is 80 degrees. I know this central angle is also 80 degrees. Well, the farther away, if I was to take point C and actually pull it and stretch it, you can see that that angle becomes thinner and thinner until it hits what we call an inscribed angle, which means you pulled it back all the way so that the vertex becomes on the circle. So the actual vertex right here gets pulled back and it becomes on the circle. And an inscribed angle is half as large as the intercepted arc. So because that blue arc is 80, I would say this inscribed angle is 40 degrees. And again, we've talked about this, we've proved this. I just want to show you guys once again. If this angle is 60 degrees, we know that the intercepted arc has to be twice as big, again, because it's inscribed. So this has to be 120. If this blue angle is 70, then its intercepted arc has to be twice as large, so 140. And then lastly, if this angle is 50, its intercepted arc right here has to be twice as big, so 100 degrees. And if you were to take all three of those arcs and add them together, I guarantee you get 360 degrees. Just like if you were to take all three of these angles inside the triangle and add them up, you get 180 degrees. Again, inscribed versus central, okay? We're going to talk about two more types of angles. Okay, so here, I left these right here as an example, central and inscribed. And we're going to talk about how to find other angles inside the circle or how to find an angle outside the circle. Okay, so here we go. So to find an angle inside the circle, we need what's called the two intercepted arcs. So I'm hoping you guys agree that these two arcs add up. If I was to add them up, add those two intercepted arcs up, those two arcs add up to 120 degrees. Well, if you split that in half, because again, you have two angles that are creating that 120 degrees. So if you divide that by 2 or cut it in half, you get 60 degrees. That's how big each of these angles are. Okay, so again, you add the two intercepted arcs up and then you divide it by 2. Add the two intercepted arcs up and then divide by 2. If your angle is on the outside, okay, you're going to take your two intercepted arcs again, except this time we subtract them, so 120 minus 20, and again, then you're going to divide it by 2, or take half. So this one would be half of 100, which is 50 degrees. So this angle right here on the outside is 50 degrees. Now, of course, they're not always going to be that pretty. That was a secant problem. Sometimes we're going to have a tangent. Let's do down there. Tangent secant problem. You do them all the same way. Look at this is the intercepted arc right here. Okay. And this is the intercepted other part of the arc. And again, because we're talking about this exterior angle, it's always going to be 1/2 the arc minus the other arc. Spelling things wrong. It's 1/2 the larger arc, the bigger arc, take away the smaller arc. Okay, so if this arc was 200 degrees and this arc down here was 80, to find this angle, it would be 1/2 200 minus 80. And of course, you guys can do some of this in your head, 120, and then take half of that. So this angle right here ends up being 60 degrees. Okay, so you're really taking a look at where these angles are. If the angles are on the outside, it's 1/2 or subtract the intercepted arcs and then divide it by 2. Whereas this one is you add the intercepted arcs and divide it by 2. Okay, so if the other angle is inside the circle or if the other angle is outside the circle. And that is it. I have nothing else fun. Let me pull up the book. I don't think there's anything else fun for 10.5 that I wanted to talk to you guys about. You guys are probably done right now. You're like, I quit. And the book has great notes, guys. I love when you guys read the book. So we've done all these. Again, they talk case by case basis. Okay, about your inscribed angles. They call these, so the ones that I talked to you about, some, the inside angles, they call them chord angles. They have all these fancy names for them. Again, it's the same thing as I just taught you before. This is just a little bit more intense. They go through the proofs of the actual theorem. Again, you're just subtracting the intercepted arcs. Okay, they did one just like me, 200 minus 60, and then they took half of it. 100 minus 20, and then they took half of it. This is a tangent problem, so these are easy because the full circle is 360. So if this is 100, the rest of the circle has to be 260, and when you subtract them, 260 minus 100 is 160, and then take half of it. This angle out here is 80. Okay, so there's, I feel like, they try to make this so complex, and it's not. It's just if your angle is on the outside, half of the intercepted arcs. If your angle is on the inside, add the arcs and take half of it. We know the central angle, we know the inscribed angle, and a tangent chord angle, which is the same exact thing as an inscribed angle. But like I said, they try to complex all this stuff. And that's it. That's it for 10.5.